Hey everyone, we're going to talk about section 9-4. 9-4 gets us into a cool new symbol, but we're going to begin first with what are we trying to accomplish. This is actually the third video I've shot because the first two I've been unhappy with. So let's check out something pretty straightforward, right? Let's talk about a linear pattern like this one, y equals 2x plus 1, or we could rewrite it as a function. We could write it as f of n, and then we would take 2n plus 1, and that wouldn't really change it, right? We're still just doubling the input value and adding 1, and that would give us the output value. So if I have a table of values, instead of x and y, let's go ahead and put n and f of n, right? Still basically just f and y, x and y. And let's go ahead and do 1, 2, 3, 4, and 5 for the sake of argument. So if I make a table, 1, put the 1 in here, right? 1 times 2 is 2 plus 1 is 3. 2 in there is 2 times 2 is 4 plus 1 is 5, and 7 and 9 and 11, right? So nice and simple. It would be easy to use that function, f of n equals 2n plus 1, and fill in a table. Now, if I wanted to add up, where I wanted to find the sum of all of those values, I could do a couple different things. I could just write down the first however many values I wanted to add, right? Let's say I wanted to add the first 5 values. I could just write these down, and then I suppose I could just add them up with a calculator or just do them in my head or whatever it would be, right? Well, I can also do it using this kind of fun new formula. So if my goal is to sum some sort of a series or sequence, especially one that is arithmetic, right? And arithmetic means that it has essentially that it has a slope that does not change, or it has some sort of constant interval. So constant increase, in this case, plus 2, plus 2, plus 2, which in this example happens to be our slope. As long as it's arithmetic, then we can go ahead and find the sum pretty easily by either just adding them all up, or watch this. I could take the first number, take the last number, and add them together, multiply that by the number of terms I'm adding, in this case 5, and divide by 2. Now, there's reasons why we're doing this, but in a short video like this, I'm not going to get into those reasons. I'm simply going to offer up this as a rule. And let's see, 3 plus 1 equals, you can pause and go back anytime you want. So I'm going to go ahead and cheat a little. 3 plus 11 is 14. 2 goes into 14 7 times, and 5 times 7 is 35. And sure enough, 3 plus 5 is 8, plus 7 is 15. 9 and 11 make 20, and 15 and 20 make 35. And look, these two match up. So whether we do it kind of over here with just write them down and add them, or whether we use this new fun rule, that works also. So either one works. The generic form of the new rule is going to be this. It's going to be the number of terms. So in our example, it was 5. The first term and the last term added together, and then the whole thing divided by 2. So we have a rule that will help us get a sum of a series of numbers. And that actually, in essence, is kind of everything that we need. I do want to suggest, though, that that is the best way to do, or at least in my opinion anyway. I'm going to scroll up here to find one, right? Let's say a problem like this one. Now, your little brother or sister could add this one up without this fanciness, but let's go ahead and say just one more time, S of n, the sum of n terms, in this case, the sum of the first 4 terms, is going to be, there's 4 of them, so 4. The first one's 2, the last one's an 8, and we divide it by 2. So 4 times 10 divided by 2, that's 40 divided by 2, so 20, right? So your little brother or sister would have just done that. We're going to use something fancier, but we all get the same answer. Okay, no big deal. Now what happens if we have something like this one? Now this is a pretty basic example, right? We could go ahead and establish it's arithmetic. It's going up by 1 every time. No surprise there. Now, could we just write 8 plus 9 plus 10 plus and then just add them all up? Absolutely. But let's get a little bit more creative. Let's pretend that we don't want to do that. Or let's pretend this is 111 or 1,111 or whatever the case may be. Let's go ahead and undo that kind of modification. Well, let's check out a new thing. The new thing is going to be, we could do the same move as long as we knew how many terms there were. All right, well, let's see how many terms there were. So if this is term number 1, this is term number 2, this is term number 3, and we don't know how many terms in between, and this is term number, n. So a rule that you might recall is to find a term in a sequence, right? A term in the sequence at the nth location is to take the starting value, in our example it's 5, add the difference each time. In this case, 5 plus 1 is 6, 6 plus 1 is 7, so the common difference is 1. And then we multiply that by the number of terms. Now, the problem is we don't know how many terms. We know we have 3. We know we have a fourth one at the end. We don't know how many are in between, so we're going to call that n. All right. Well, what do we know? We know that the last term is 11, so we can go ahead and say that this thing is 11. So let's take this out. And we know that the first term is 5, so this thing can be a 5. So let's remove this and put a 5 in there. And now I think we can solve this. So 11 is 5 plus 1 times n. So n is 6. Okay, so that means there's 6 terms, but I would want to point out that there's 6 terms here plus the original one, so there's actually 7 terms. All right, you follow me? So if you do, we can now use that summation formula where we say the number of terms, the first term, and the last term divided by 2. And I'm not going to finish this one out, but you could do that, and that would give you the sum of 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11, those first 7 terms. Okay, so that's all fine. None of that seems really earth-shattering. So let's do one more thing here. Let's go back to our original example. We're down here at the bottom. And let's go ahead and say, is there a way to tell somebody that we want to add this sequence together? Or maybe we want to add even more than just that sequence, right? How could we tell somebody that we want to add that sequence together? Well, here's what we can do. We can use this thing called summation notation. And it has a new, oops, I didn't spell that right. Notation, there we go, summation notation. And it has a new symbol called sigma. All right, sigma is a capital Greek letter. And that Greek letter has some stuff next to it. So at the bottom of the Greek letter sigma, right, sigma, S-I-G-M-A. At the bottom of sigma, we're going to go ahead and put the starting n value. Usually that's going to be 1. And at the top, we're going to go ahead and put the number of terms. And over here, we're going to put the explicit formula, the EF, or the direct formula if you prefer. Now, what does all that mean? Let me show you what I mean by that. Oops, not with that tool. So over here, I'm going to switch colors so it stands out a little bit. Let's use purple. I'm going to go ahead and say sigma. All right, I'll put the little wings on there, but you don't need those. You could just leave it like that. I'm going to say that our n value starts at 1. So n equals 1. That's our starting value. And how many of them are there? There are 5 of them, so I'll put a 5 up here. And what's the pattern that controlled our output? It was this, 2n plus 1. So I'm going to write 2n plus 1. And this thing tells me, and I'm going to use the highlighter tool to kind of point it out, it tells me as a user to add up the first 5 terms, starting at the number 1, using this as the function. Okay, that's the information that it's telling me, and that's what it's asking me to do. So how do I do that in practice? Let me go ahead and find a good example here. This is the document that my students will be using on Tuesday. Let's go ahead and look at this one right here. Find the sum of each finite series. Finite simply means we know that it stops at some point. And in this particular one, it starts at 1 and it goes 10 terms long. So here's what I'd like to do, to be honest. I want to use this formula. I want to use the sum formula, the n and the a sub 1 plus the a sub n over 2. I'd like to use that formula for anything that's arithmetic. Arithmetic means it has a slope or it has a common difference. So here's what I'm going to do. I'm going to go ahead and say if n equals 1, I'm going to put 1 in this place. So 3 times 1 minus 4. So 3 minus 4 is negative 1. And I'll put a negative 1 here. Okay, so negative 1. Now I'm going to go ahead and say, well, the 10th digit later, let's clean some of this up. I'm usually just going to put this right here. All right, or it's 10 later than 1. So 1, 10 of them. So I'm going to do 3 times 10. 3 times 10 is 30, of course, minus 4 is 26. So that 26 is going to go, 26 is going to go here. So 26. And how many terms? Well, there's 10 terms, so the 10 is going to go right there. So put a 10, put a plus, put a divide by 2, and I'm going to go ahead and calculate my answer. So 10, 25 times 2, that's going to be 125. All right, and that's the sum of the first 10 digits that follow this pattern from n equals 1 to n equals 10. That's kind of how that works, right? Now, can we get creative with lots of other stuff? Sure. Are there videos out there that are longer than this one? 100%. But let's see if that's enough to get you moving. You can, of course, go back and watch if you need to, but I will see you probably the very next day. Good luck working through this document to the best of your ability and working through these arithmetic series.